to one and all. In the previous video, I have asked some questions for you. That is, when zinc reacts with sodium hydroxide, what are the products formed? Aluminium reacts with sodium hydroxide, what are the products formed? Aluminium reacts with sodium hydroxide, what are the products formed? The same manner, silver reacts with copper sulfate solution, what happens? What are the products formed? Right, these three questions I have asked in the previous video. So now let us see the answers for this. Generally, any metal will react with acid to produce hydrogen gas. Displaces hydrogen from that, produces hydrogen gas, along with that some salt is formed. And non-metals will react with the bases. The same way, non-metals will react with the bases, some other products will be formed. But here if you see, the zinc and aluminum, they have the special properties, and also sodium hydroxide or potassium hydroxide or sodium hydroxide are also having special property to react with the metals. Remaining any other bases if you take, they don't react with the metal. But here these two metals will react, and the bases also sodium hydroxide and potassium hydroxide are able to react with the metals. So now here what happens? Generally, as we have seen, metals will react with the acids to produce a hydrogen gas. Here, these metals will react with the bases to produce the hydrogen gas. Along with the production of the hydrogen gas, they produce some salt also. What is that salt here? Here it will produce sodium zincate. Sodium zincate will be formed here. Formula is Na2ZnO2. Na2ZnO2. In the same manner, aluminum also react with the sodium hydroxide, produces hydrogen gas. Along with that, it is going to produce NaAlO2, whose name is sodium aluminate. And here if you come to the one more question, which I have asked previously, silver reacts with the copper sulfate. Here the reaction is not possible. Why it is not possible? As we know already that metals, whenever we see the displacement reaction, we have to see the element whatever is present outside, means which is not present in the compound, should be more reactive than the metal which is present in the compound. As you see here, copper is more reactive than silver. So that is why this reaction is not possible. Right? So coming to today's topic. Find the position of the element in the modern periodic table. How can we find the position? So before going to find the position of the periodic, means the element in the modern periodic table, we should be able to write its electronic configuration. So you know already that electronic configuration is nothing but systematic arrangement of the electrons in the orbitals of the element. Systematic arrangement of the electrons in the orbitals of the element. So here now one example we'll take here. But before going to this, we should know what is this modern periodic table. It is given by the scientists known as Moseley. It will contain 4 blocks, S, P, D, F. 4 blocks are there. Along with that, 7 periods are there. Along with that, 18 columns are there, which are grouped under 16 groups. 16 groups, 1A, 1B, 2A, 2B, like that up to 8A and 8B. Right. So here we are going to find out in which group, in which period, in which block that particular element is there. Without seeing the periodic table, we will be able to say that. Now some examples we'll see here. Now first example, we have some element is given for us whose atomic number is 12. Here no need to say its name. If you know the name, it's better. Otherwise also we can say in which group, in which period, in which block that element is there. How can we say that? Now based on this atomic number whatever is given, first of all we should be able to write its electronic configuration. So how to write that electronic configuration? Based on here we have to write this NLX method. What is that NLX method here? First of all we have to write shell number. Next, azimuthal quantum number. Based on this, we should be able to write the subshell name. Then here we have to write how many number of electrons are present in that particular subshell. Now, coming to this 12 atomic number, what we have to do here, one by one we have to fill that. With the electrons. One by one in the sense the orbitals should be filled with the electrons. So how to fill that? First of all, first shell should be filled. First shell, in that S subshell is there, that has to be filled. with 2 electrons. Maximum number of electrons accommodated in S subshell is 2. Then coming to second shell. First shell contains only one subshell, that is S subshell. Coming to S, second shell, here it has 2s and also 2p. 2s and also 2p. In 2s, 2 electrons will fit maximum. In 2p, 6 electrons will fit maximum. So 2s2, 2p, 6. We have completed. So now you count the number of electrons. Is it matching with the number given? 2 plus 2, 4, 4 plus 6, 10. Now here, third shell also we can take because it's not completing. This number we are not getting here. So let us write third shell in that also. S subshell is there in that 2 electrons. Now you count 2 plus 2, 4 plus 6, 10 plus 2, 12. So 12 electrons we got here. The element is containing 12 electrons like this. We have written the electron configuration. Now based on this, we can say what is a block name. First of all, we will see how to say the block. So what is this block name? How we have to say? Block name is equal to the last electron into which orbital it is entering. The last electron is the sense we have to say one particular name here called as differentiating electron. Differentiating electron is nothing but the electron which is making the difference with the previous element. Compared to the previous element, wherever we are getting the difference, that becomes a differentiating electron. So here this second electron of this element, actually the element name is here magnesium. We can say the name. Otherwise also you can say better what is the position of the element. Now here second electron is making the difference. So that second electron becomes a differentiating electron that is entering into S orbital. So what we have to write here, block name as S block. Block name as S block. Next, we have to say here, what is the period number? What is the period number? How we have to say the period number? Period number we can say very easily how many number of shells are there. Number of shells is nothing but the period number. What is that number of shells here? First shell, second shell, third shell. Totally 3 shells are there here. In this atom if you take, here it is having 3 shells. Along with that one nucleus also. In first shell it has 2 electrons. 2 electrons. Second shell it is containing totally 8 electrons. In 2s 2 electrons, 2p 6 electrons. Third shell it contains 2 electrons. So this is the structure of this particular atom. So in that if you see total number of shells, how many are there? First, second, third. 3 shells are there. So period number becomes 3. Next, how to say the group number? Group number. Here we have 2 terms, group number, column number. Many of the students will confuse with the group number and group name. Based on the column number, we can simply write the group number. And group name also is there, like 1A, 2A, all these are the names of the particular group. Group numbers means 1, 2, 3, 4, 5, 6, that are the numbers. So whenever we are writing the Roman numbers, there we should be somewhat careful. Now, first of all, we'll try to write group number. As the element belongs to S block, here we have a formula, last shell how many number of electrons are there, that becomes the group number. Whenever any element belongs to S block, number of electrons present in the last shell, becomes the group number. How many number of electrons are there in the last shell? 2 electrons. So the group number is second group. Second group has a name here, that is 2A. 2A. Roman number 2A, otherwise we can write second group. Right? One more example also we'll see here. We have here one element has atomic number 14. Atomic number 14. There also we'll try to write the block name, period number and also group number for that element. So now let us take here 14. Atomic number is 14 here. Again we'll try to write the NLX method electronic configuration. We'll try to write the block name, group number and also period number. Now here we have the element 14. We'll try to write the electron configuration in NLX method. 1s2, 2s2, 2p6, 3s2, 3p2. 3s2, 3p2. Right. Now here block name, how we have to write? Differentiating electron is entering into p orbital. That is why block name is p block. Then what about the period number? How many shells are there? First shell, second shell, third shell. Don't add these all numbers. Just to see the largest number whatever is there. 3. So period number is 3. Then what about the group number here? It belongs to P block. No. Before we have done with the element which is present in the S block. There we have counted already how many number of electrons are there in the last shell. That becomes a group number. But here what we have to do here for writing the group number, 10 plus different number of electrons present in the last shell. Number of electrons present in the last shell. How many number of electrons are present in the last shell totally? 4 electrons. So 10 plus 4, that becomes the 14th group. 14th group, otherwise in Roman number we can write 4th A group. 14th group or 4th A group. Roman number 4th A or 14th group. We can't write this as 4th group. In Arabic numbers we can't write like this. It's wrong. It's not 4th group, it is 14th group. Roman number 4th A or 14th. Right? Like this, P block elements we can write whenever they are entering, the differentiating electron is entering into P block, P orbital, we can write the block name as P block, and group number we are going to write by adding that last shell number of electrons plus 10. Then we will get the group number. Right? In the same manner, some other element we'll see which belongs to D block also. Which belongs to D block. Now, here I am taking some element whose atomic number is 23. Now, this element belongs to D block I am saying. How it belongs to D block? How can we say that it belongs to D block? That also we'll see here. Now, first of all, let me write the electron configuration in NLX method. How we have to write that? 1s2, 2s2, 2p6, 3s2, 3p6. Now, just count here how many electrons we got. 2 plus 2, 4 plus 6, 10 plus 2, 12 plus 6, 18 electrons. But 23 we have there. So, remaining we'll write here. According to Aufbau principle, we have to follow here. 3s2, 3d, 3. Now, once we'll count. 2 plus 2, 4, 6, 10, 12, 18, 18 plus 2, 20 plus 3, 23. Now, 23 electrons we have completed. Block name, how we have to write? Differentiating electron is entering into D orbital. So, block name is D block. Then what is the period number here? Totally how many shells we have? Don't see the last one. Just to see the largest number. What is there? 1, 2, 2, 3, 3, 4, 3. So maximum number is 4. So here whenever we are writing this particular atom, what we have to do here? 4 shells are there here. Along with that one nucleus. Nucleus contains 23 protons. Then along with that it has first shell contains 2 electrons. Second shell contains totally 8 electrons. 8 electrons. Third shell if you see 2 plus 6, 8, 8 plus 3. Totally 11 electrons are present. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 electrons are there. Last shell contains 2 electrons. This is the 4th shell. So period number means how many shells are present? 1, 2, 3, 4. Total number of shells are 4. Next, coming to group number. How we have to write the group number? Now here you see the last shell we can give the number as n. Nth shell. Nth shell is nothing but 4th shell. Here in this case it is 4th shell. Now this becomes n minus 1th shell. N minus 1 is nothing but penultimate shell. Last shell is known as ultimate shell. Before that shell is known as penultimate shell. So ultimate shell, number of electrons present in the s orbital. Penultimate shell, number of electrons present in the d orbital. Both of that we have to count. That means ns electrons plus n minus 1 d electrons. Ns electrons and n minus 1 d electrons. Ns electrons means how many are there in the 4th shell? Because here nth shell means nothing but 4th shell. So in that 4th shell how many number of electrons are there? 2 plus 3rd shell is containing 3 electrons. Right. So this is nothing but the 5th group. 5th group. How to give the Roman number then? How to write the Roman number? So here in this modern periodic table if you see, just this one we have to remember. First we have first A, second A, after that third group, B groups will start. Third B, fourth B, fifth B. So first group, second group, third group, fourth group, fifth group. So the name of this group we can write it as 5th B. If you don't know the Roman number, you can leave it there. But this one, whatever the number we are writing here, we have to write it compulsory, correct we have to write. So 5th group, it is nothing but 5th B group we have to write. Like this, we can write the block name, period number, group number for any element. If you know the atomic number, you are able to write the electron configuration, then its position we can say easily. Then what about the element if it is present in the F block? F block means by seeing the last shell, means by seeing the differentiating electron. If it is entering into F orbital, you can write it as a element is present in the F block. Then how to write period number? Either it may be present in 6th or 7th. Then group number, only one group is present for F block elements, that is third B. In third B only all the elements will be present. In this third B group only all the elements will be present. So no need to find out specially for those. Just you try to remember how to find out the position of the element if it is present in S, P, D blocks.